What's up everybody and welcome to a new video. And in this video we're going to go over my notes for the def keyword in Python. Namely, the def keyword allows you to define your own functions, and at the very minimum the function needs a name and a body. So now let's use this def keyword to create a function. So therefore we simply here say def, and now here we have to specify the name. So let's create a function that prints out the first 10 Fibonacci numbers. So let's call this simply first 10 Fibonacci numbers, and then here you have to specify parentheses and then a colon, and then when you press enter, then here you have to then specify the body. So here I've already prepared the body, so let's now run the cell, and now let's simply call this function. So let's say here first 10 Fibonacci numbers, and then here we get our first 10 Fibonacci numbers. So that's how you can use the def keyword to create your own functions. Then the next note states that functions can receive input via parameters or arguments, i.e. instead of just always doing the exact same thing, they can then do something based on the input that they receive. So for example, our function here always just prints the first 10 Fibonacci numbers, but let's say that we want to define it in such a way that we can specify how many numbers it should print out. So if it should print out 10 or if it should print out the first 100. So therefore, let's simply call this function then Fibonacci numbers. Then here within those parentheses, we can specify the parameter. So let's simply use here an n to specify how many numbers we want to print out. And then here in this for loop, we're going to use this n. So then let's define it in such a way. And then here we're going to call it. So here let's use a 3 as an argument. So now if I run it like this, then we get here the first 3 Fibonacci numbers. And let's also do another call. So here in this case, let's simply then say 10. And then again, we get here the first 10 Fibonacci numbers. So that's how we can use parameters to change what a function does based on the input that it receives. And then here, I also have some side notes. And the first one states that providing the wrong number of arguments results in an error. So for example, if we call here our Fibonacci numbers function, and then don't specify here an argument, then we get here this type error, and it says that Fibonacci numbers missing one require positional argument, which is here this n. And also if we then do it the other way around, so if we here specify too many arguments, then we get this result or this error here, where it says Fibonacci number takes one positional argument, but two were given. So that is the first side note here that I wanted to cover. And then the next side note states that you can have multiple parameters. So for example, our function here only has one. So now let's add another one. So therefore then here we put in a comma, and then we can specify our second parameter. So let's call this here show index. And what this should be for is to specify if we want to show here an index for our Fibonacci numbers. So for example, so that we then can see if this 3 here, if this is the 5th Fibonacci number, or if this is the 6th Fibonacci number, without needing to count. So to achieve that, I've prepared here this code. So let's change our function to look like this. And then here, when we make the call with the 10 Fibonacci numbers, let's here set the show index parameter to true. So now if I run it like this, then we get here those indices, and then we can see, okay, the 3 here is the 5th Fibonacci number. And then again, if we set it here to false, then those indices are not printed out anymore. Okay, so those are the two side notes that I wanted to cover. Then the next note is about the different types of parameters or arguments. However, before we get to that, I want to cover what this asterisk here is for. Namely, this refers here to these parameters and arguments. And namely, the terms parameter or argument can be used interchangeably. However, technically more precise would be to say that the parameter is the variable name specified in the function definition, whereas the argument is the actual value or object that is passed to the function. So here in our Fibonacci numbers example, this n and this show index here, these are parameters, and the 10 and the false, these are arguments. So then when we call this function, these arguments here are assigned to the parameters. Okay, so that's the difference between parameters and arguments. So now let's get to the different types of parameters or arguments. And here the first note is about positional or keyword arguments. Namely, arguments can be passed by either their position, so those would be then positional arguments, and in that case then the order matters. So for example, here in this function call, we specified the 10 and the false. So what happens here is that this 10 gets assigned to the n, and the false then gets assigned to this show index parameter. However, if we now do it the other way around, then the following happens. Namely, if I say here then Fibonacci numbers, and then here false, and then 10, then if I run this, then you can see that nothing gets printed out. So that's because in this case here on this function call, this false here is now assigned to the n, and then here within our function where we say here for I in range n, then what happens here is that this false gets interpreted as a 0. So we are saying here for I in range 0. So therefore then you are not executing anything within this for loop. So those are then positional arguments, and then arguments can also be passed by using the parameter name. So those would be then keyword arguments, and here then the order doesn't matter. So for example, what you can do here is say n equals 10, and here let's actually make this here a 5 so that it doesn't print out so many numbers. And then here we're going to say show index equals false. So if I run it like this, then we get here the first 5 Fibonacci numbers without an index. And now if we do it here the other way around, so here we're going to say first show index and set that to false, and then here we're going to say n equals 5. And if I run it like this, then it also prints out the first 5 Fibonacci numbers, even though here the order of these parameters was changed. And that's because in this case Python then actually knows, okay, this false here should be assigned to a show index parameter, and this 5 here should be assigned to the n parameter. So those are positional and keyword arguments. And then here the second note states that you can also use a mixture of both types. However, in that case, positional arguments must be stated before keyword arguments. So for example, what you can do here in the function call is to say the following. So you can say, or you can specify here a 5, and then afterwards say that show index should equal false. So if I run it like this, then it works. However, if I do it the other way around, so if I say n equals 5, and then here delete this show index parameter and simply specify here this false, then we get here a syntax error because a positional argument follows a keyword argument. So this positional argument here follows then this keyword argument. Okay, so those are then my notes for positional and keyword arguments. Then the next type of parameters or arguments are positional-only or keyword-only arguments. Namely, it is possible to specify parameters to be only used with positional arguments or only with keyword arguments. And to demonstrate that, I've prepared here this function. So here we have 3 parameters, and we also have here in between those parameters, we have here this / and this asterisk. And any parameter that gets specified before this / is then a positional-only parameter, and any parameter that gets specified or listed after an asterisk is then a keyword-only parameter. And parameters in between those are then or can then be used as positional or keyword arguments. So now to see this function here in action, let's make some function calls. And here in the first function call, we're only going to use positional arguments. So therefore then we say here 1, 2, and 3. And now if I run it like this, then we get here this type error because our function takes 2 positional arguments, but 3 were given. So only for those first 2 parameters here, we could use positional arguments. However, we used here positional arguments for all of these 3 parameters. So now let's make another function call. And this time for this 3 here, let's use actually a keyword argument. So here we're going to say keyword only equals this 3. In that case, then our function call works because we used here this keyword argument for this 3. Then next, let's also use here for this 2 a keyword argument. So we're going to say then here positional or keyword should be equal to 2. In that case, then we also get here this print statement where it says function call works. And then lastly, let's also use here for this 1 a keyword argument. So there we're going to say position only equals 1. And in that case, then we get again an error because our function here got some position only arguments passed as keyword arguments. So because we used here this keyword argument, we get this error because this actually is only a positional-only argument. Okay, so those are then positional-only and keyword-only arguments. Then the next note is about some general guidelines for when to use positional-only arguments and keyword-only arguments. So let's start here with the positional-only arguments. Namely, here the first guideline is that if the name of the parameters shouldn't be available to the users. So for example, if they don't have any real meaning. Then the next guideline for when to use positional-only arguments is if you want to enforce that the arguments are passed in a certain order into the function. So if you always want the arguments to pass in a certain order, then you can also use positional-only arguments. Then here, the third guideline states that if a regular parameter or argument and the keyword argument passed via keyword args might happen to have the same name. So we will talk about keyword args here in a moment. However, I now just want to quickly show what I mean by this guideline. And therefore I've prepared here these two functions. So we have function 1 and function 2. Both have the parameters x and then these keyword args, and both print out the x and the keyword args. The only difference is that here in function 2, we specified this x to be a positional-only argument. So now when we call function 1 and then say here simply specify a 1 and then say x equals 2, then in this case we get here an error because function 1 got multiple values for argument x. So what happens is that here Python tries to assign this 1 to this x here, and then however from this keyword args it also gets here this parameter where it says x equals 2. So it doesn't know should x now be 1 or should it be 2. However, if you do the same thing with function 2, so we say a function 2 and then 1 and x equals 2, then we don't get an error and we actually print out the x and also the keyword args. And that's because in function 2 we specified x to be a position-only argument. So therefore then Python knows that this one here should be assigned to this parameter. So this is what I mean by this guideline here that says if a regular parameter or argument and the keyword argument passed via keyword args might happen to have the same name. And then the last guideline is for an API. Namely, if you want to prevent breaking the API due to changing a parameter's name at some point in the future. So to show what I mean by that, I've prepared here this code snippet. So here we have the function square, which simply calculates the square of x. And then here within this print squares function, we call this square function. And here we say x equals number. So now if I run it like this, then here those squares get printed out. And now let's say at a later point, we actually decide to rename here this x and we want to rename it to number. So if I call this now number and then run our code again, then we get here this type error because square got an unexpected keyword argument x. So what happens is here, when we call square, we still say x equals number. However, our parameter for square is not called x anymore. So now let's see what happens when we use here a positional-only argument. So therefore, let's use again this code. Only this time, however, we're going to specify that this x here should be a positional-only argument. So we're going to put in here this /. And then here, when we make here this function call, we can then not use here this keyword argument. So we have to delete that. So then if I run it like this, then we get here our squares. And then again, let's say that we want to rename here the x. So we're going to then rename it to number. And now if I run it like this, then again here the squares get printed out and we don't get an error. So this is what I mean by this guideline here. And with that now we've covered all my guidelines with respect to positional-only arguments. So now let's get to the keyword-only arguments. And here I only have one guideline, and this states that if the function call is better to understand with keyword arguments and therefore you want to enforce that. Okay, so those are the guidelines. And with that now we've covered here all my notes with respect to positional-only and keyword-only arguments. Then the next type of parameters or arguments are called args. And here the first note is about the purpose of those args. Namely, sometimes you might want to accept an arbitrary number of positional arguments. And you can do that by putting an asterisk right in front of the parameter name. And then when calling the function, the passed arguments are then packed into a tuple. And if no arguments are passed, then the tuple is empty. So to demonstrate that, let's create here a function that is called print args. And then here we're going to create such an args parameter. So we're going to use here the asterisk and then say args. And then within the function, we're going to print out the type of the args so that we know what type that object is. And then we're also going to print the args themselves. So now let's call this function here without specifying any arguments. So we're going to run it like this. And in this case, then you can see these args here are a tuple. And in this case here, it's an empty tuple. So now let's call this function again with an argument. So we're going to say print args. And then here going to specify simply a 1. So if I run it like this, then we get here a tuple that contains here this 1. And if I run it, for example, with 1, 2, then our tuple here contains now the 1 and 2. And if I run it with 1, 2, and 3, then our tuple now contains here these 3 numbers. Okay, so that is the purpose of args and how you can generally use them. Then the next note states that calling such a parameter args is just a convention, and you can actually name it whatever you want. So to demonstrate that, I've prepared here this function. So this is called SumUp, and here we have the parameter numbers, and in front of that parameter is also here this asterisk. So with that now we can pass in here an arbitrary number of positional arguments and then simply calculate the total of that. So for example, if I say here SumUp and then only pass in here a 1, then we get a 1 as a result. If I say here 1, 2, then we get a 3. And if I say here 1, 2, 3, then we get here a 6. So as you can see, you can name these args here actually however you want. Then the next note states that args are usually listed after regular parameters. And to show what I mean by that, I've prepared here this variation of the SumUp function here. And here we now have these 2 parameters. So first we have this message parameter, and then afterwards we list here these args. So for example, then if I want to use this function, I can then say here SumUp, and then pass in the message. So for example, then the total is, and then colon, and then here we can use our args. So we can then, for example, say 1, 2, and 3. And if I run it like this, then it says now the total is 6. So this is what I mean by this note here that says that args are usually listed after regular parameters. And then here I also have some side notes. And the first one states that any parameter that is listed before args in the function definition is quasi-positional only. So this message parameter here is quasi-positional only. So therefore then, if we say here message equals this particular string, then we get here actually this syntax error because the positional argument follows keyword argument. So to be technically more precise, what happens here is not that this message parameter here is position only, but instead what happens is that when you use keyword arguments, then you're not allowed to use positional arguments afterwards, as we have seen earlier in this video. So here then, because we are using here this keyword argument and then afterwards these positional arguments, therefore then we get here this error. Okay, so that is the first side note here that I wanted to cover. Then the next side note states that any parameter that is listed after the args in the function definition is keyword only. So for example, if we switch around here those parameters, so if we first say numbers and then the message, then this message parameter now is a keyword only parameter. So therefore then here in our function call, we also need to specify the numbers first. So let's delete here the message. And then at the end, put in here our string that contains the message. So if we run it like this, then we get here an error because SumUp is missing one required keyword only argument, which is here the message. So here then we actually have to say message equals and then our string. And if we run it like this, then the function now works again. Okay, so those are the 2 side notes here that I wanted to cover. So now let's get to this general side note here. And this simply states that it also works the other way around, i.e. The elements of a data structure or string can be unpacked into positional arguments. And to show what I mean by that, I've prepared here this code snippet. So here we have the function SumUp, which takes in those 2 parameters here, number 1 and number 2, and then it simply returns the sum of those 2 numbers here. And then here we have a variable called numbers, which is a list containing 1 and 2. And now let's say we want to call this function here, so we can say SumUp. And then let's say here for this number one parameter, we want to use here the first element in our list. So we're going to say numbers and then brackets 0. And then here for this number 2 parameter, we want to use the second element in this list. So we're going to say numbers brackets 1. And now if I run it, then you get here a 3. So it works. However, this can be done more easily with this approach here. So we can say sum up and then put in here our numbers and then simply put an asterisk in front of those numbers. So now if I run it like this, then we again get here a 3. So then what happens is that those elements here in this list, they are unpacked here into these parameters. So whereas here with those args, what we did is we packed those multiple values into one parameter. And here what we do is we unpack this one value into multiple parameters. So this is what I mean by this side note here. And with that now, we've covered all my notes with respect to args. Then the next type of parameter or argument is called keyword args, and they are very similar to those args here. So therefore then my notes here are also very similar. So first again, we have here the purpose. Namely, sometimes you might want to accept an arbitrary number of keyword arguments, and you can do that by putting 2 asterisks in front of the parameter name. And then when calling a function, the passed keyword arguments are then packed into a dictionary. And if no arguments are passed, then the dictionary is empty. So again, to show that, let's create here a function that we simply call print keyword args. And then here we create such keyword args. So we're going to use 2 asterisks and then say here simply keyword args. And then within the function, let's again type out, print out the type of those keyword args. And then let's also print out the keyword args themselves. So now let's again just run this function here without using any keyword arguments. So in that case, then you can see here we get a dictionary. So those keyword args are a dictionary, and currently it is empty. However, if I now say here keyword args, and now we can specify here some keyword arguments. So we can say x equals 1. And if I run it like this, then we get here this dictionary with this key value pair where we have the key x and the value is 1. And here you can also pass in multiple keyword arguments. So we can also say here, for example, y equals 2. And if we do that, then we have here this dictionary with those 2 key value pairs. So that is the purpose of those keyword args and how you can use them. And then the next note states that calling such a parameter keyword args is just a convention, and you can name it whatever you want. So to demonstrate that, I've prepared here this example function. So this is called create user profile, and here we are using those keyword args. However, we are calling them user info. And then here in this function, we simply populate here this dictionary. So now let's call this function here. So let's say create user profile. And then for the first name, let's say that is John. And then for the last name, let's say that is Doe. And if we run it like this without specifying here any additional keyword arguments, then we get here this dictionary where we have the first name John and last name Doe. However, we can also specify an arbitrary number of keyword arguments. So therefore, we could, for example, here say email equals and then John at email.com. And now if we run it like this, then we also have here this email entry in our dictionary. So as you can see, you can really name those keyword args here however you want. Then the next note states that keyword args need to be specified after args. So to show that, I've prepared here this simple function. So this is called test, and here we first specify args and then keyword args. And if I run it like this, then there's no problem, so we don't get an error. However, if I do it the other way around, so if I first specify here the keyword args and then the args, then we get here this syntax error. So this is what I mean by this note here that says that keyword args need to be specified after args. So now let's go over this side note here. And this again simply states that it also works the other way around, i.e. The keys and values of dictionary can be unpacked into keyword arguments. And to demonstrate that, I've prepared here this function. So this is called greet customer. It has the parameters first name, last name. And then here we simply have 2 print statements, hello, first name, last name, welcome back. And then here I create here this variable user info, which is a dictionary where the key is your last name Doe and first name John. So now let's say that we want to use here this function with this dictionary here. So the way that we would do that is by saying here greet customer, and then for the first name parameter we would then provide our user info, and then brackets first name, and then also the same thing for the last name. So then here for the last name we would then say user info brackets last name. And now if I run this, then we get here this result. So hello John Doe, welcome back. And this again can be done easier with this approach here. So if we say here greet customer, and then simply put in our user info variable, and then to unpack this dictionary, what we do is to simply add these two asterisks in front of that. And now if I run it like this, then you can see that we again get here this result, hello John Doe, welcome back. So whereas before, what we did is we packed multiple values here into one parameter. And in this case now we are unpacking one value into multiple parameters. So this is what I mean by this note that says here that it also works the other way around. Okay, so with that then, we've covered here all my notes with respect to keyword arguments. So now let's go over the side note here. And this states that the different types can be used in combination. So the different types here of parameters or arguments can be used in combination. And to demonstrate that, I've prepared here this example function. So here I've prepared an example function where I use all the different types of parameters or arguments. So the first parameter here is a positional-only argument. Then here we have a positional or keyword argument. Then here the args. Then here a keyword-only argument. And then here the keyword args. And then within the function I simply print out all of these different parameters here. So now let's make some function calls where we use a different combination of these parameters here. So let's start with a function call without args or keyword args. So one way of doing that would be to say here a function, and then here for this positional-only argument we could then specify a 1. Then here for this positional or keyword argument we can specify a 2. And then here for this keyword-only argument we can then say keyword only, and we want that to be a 5. So now if I run this, then you can see that it prints out here a 1, a 2, an empty tuple, then here this 5, and then here this empty dictionary. So that's one way of making this function call, but we can also do it another way, namely for the second parameter. Here we can also use a keyword argument. So therefore we can then say here position or keyword, it should be equal to 2. So if I run it like this, then we get here the same result. So that's here the first function call that I want to show. Then the next function call is with keyword arguments. So we're going to use here now those keyword arguments. So they have to be specified at the end. So then here we could say, for example, x equals 1 and y equals 2. So if I run it like this, then we get here this dictionary. And we can also do it in this way here, where we use here the keyword argument for the second parameter. So here we can also say x equals 1 and then y equals 2. And then we get here the same result. So that's the next that I want to show. Then the next function call is then with args. So therefore, let's again delete here those keyword args. So if we want to use here the args, they have to be specified after this positional or keyword argument. So they have to be specified here. So here, let's simply say 3, 4. And now if I run it like this, then we get here this tuple, which contains then this 3 and this 4. And then here, however, where we do it in this function call, where we use here this keyword argument for the second parameter, if we try to do it in here, then we get the following. Namely, we get here the syntax error because the positional argument follows a keyword argument. So those positional arguments here, they follow this keyword argument, and this is not allowed as we've seen earlier in the video. Okay, so then here, the last function call that I want to show is with args and keyword args. So here again, let's use then also the keyword args. So here we can then again say x equals 1 and y equals 2. So if I run it like this, then we have here this output where we again have here this dictionary. And again, if we try to do this here also in this function call where we use here the keyword argument for the second parameter, then again we get here this syntax error because those positional arguments here follow this keyword argument. Okay, so that is now here the side note that I want to cover, and with that now we've covered all my notes with respect to the different types of parameters or arguments that are available. So now let's go over these side notes here, and the first one is about default values. Namely, for some functions, a certain parameter might be used mostly with just one specific argument, i.e. value. And in that case, then assigning a default value to this parameter simplifies the function call. So to demonstrate that, let's again use here our Fibonacci numbers function. And let's now make a call with this function where we set the n equal to 5. And then we don't want to print out the index, so we're going to say false. So now if I run like this, then we get here our numbers. And now let's say that actually most of the time you want to use this function where you set here the show index parameter equal to false. So most of the time you don't want to see the indices. So in that case then, however, you always have to specify here a false when you make a function call. So to get around that, then you can use here a default value for the show index parameter. So you can say your show index should be equal to false. This is now the default value for this show index parameter. And now when we make here the function call, then we actually don't have to specify this false. So we only have to specify here then the n. And if I run it like this, then we get here again the same result. And however, if you actually then want to see the index, then you can also set here, simply say here true. So this will then be assigned to the show index parameter. And then we can again see here those indices. So that is the basic use of default values. Then the next note states that parameters with default values need to be listed in a function definition after all parameters without a default value. So for example, if I would try to put here this n after the show index parameter, then we get here the syntax error because the parameter without a default follows a parameter with a default. So therefore, let's again undo this change here, so that the parameter with the default is again listed after the parameter without a default. And then the next note states that default values are evaluated at the point of the function definition and not when the function is called. So to demonstrate that, let's create here a variable called I, and let's set this to 5. Then here we're going to create a function, and we're going to set the parameter equal to the default value I, and then we're going to print out the parameter. Then let's call this function here, and then it simply prints out here the 5. And now let's set here the I equal to 6, and then call the function again. And now you might think that it actually prints out here the 6. However, what it does is that it prints out here this 5. And that's because default values are evaluated at the point of the function definition and not when the function is called. So since here at this function definition, I was still 5, therefore then when we call here this function, it still prints out this 5. However, if I now copy here this function definition and then run the cell again and then call the function again, then you can see that it now actually prints out here this 6. So now to understand what's going on here, I've prepared here this illustration. So let's open this file here, and then let's see what is going on. Namely, here first, when we say I equals 5, what happens is that the 5 is created, stored in a specific place in memory, and then I points at that place in memory. And we can verify that by simply printing out here the ID. So in this case, we have then this specific ID. Then here next, where we have our function definition, what happens is that the default value is already created. And I can verify that by doing the following. So I can say here function dot and then underscore underscore and then defaults. So if I access here this attribute, then here we get a tuple with all the available default values. So in our case, we only have this one default value, therefore we only have this 5 here. So then if I say here brackets 0, then we get to the actual default value. So then what happens here is when we run this function definition is that we want to this default value variable, we want to point that at the same object that I is pointing at. So since I is pointing here at this 5, this default value variable is also pointing here at this 5. And again, we can verify that by printing out here the ID. So let's do that. So here you can see that we have here the same ID. Okay, so then here the next step, when we then make the function call, what happens is then that we want this parameter here to point at whatever the default value variable is pointing at. So since that is pointing at 5, the parameter is also going to point here at this 5. And again, we can verify that by printing out the ID. So let's say here print ID of our parameter. And then let's run the function again. And then here you can see that we again get the same ID. So now the parameter, the default value variable, and I are all pointing at the same object in memory, which is here this 5. So then in the next step here, when we say I equals 6, what happens is that the 6 is created, stored in a specific place in memory, and then I points at that place in memory. And again, we can look at that by printing out here the ID of I. So here you can see then we have here now a different ID. Then here in the next step, when we call the function again, what happens then is that the parameter should again simply point at whatever the default value variable is currently pointing at. And since that is still pointing at 5 here, we again print out then here the 5. So if I run it, you can see that it prints out here the 5, and it's still pointing here at the same ID that the default value variable is pointing at. So then next, when we run here this function definition again, then here what happens is that now the default value variable should point at whatever I here is pointing at. And since I is pointing at the 6, this default value variable is then also pointing here at this 6. So we can verify that by copying here the cell where we print out that ID. So let's run it again. And now we have here this new ID, which is the same one as the ID here for 6. And then lastly, in this last function call, what happens then is that the parameter here should then point at whatever the default value variable is pointing at. So again, let's print out here the ID. So I'm going to say ID of the parameter. So then since this default value variable is currently pointing at the 6, the parameter is also going to point at that 6 and then print out the respective 6. So if I run it again, here we get the 6. And then here you can see that this function here, or the ID of the parameter, is the same ID as the ID of the default value variable. Okay, so that is then this last note that I wanted to mention here with respect to the default values. And with that, now we've recovered here all my notes with respect to default values. Then the next side note is about annotations or type hints. Namely, they can be used in the function definition. And what you can do is you can specify what data types the parameters and or return values are supposed to be. So for example, therefore, to show that, let's again use here this Fibonacci numbers function. And now here, let's say that this n parameter should always be an integer. That's because we can't, for example, print out 5.5 Fibonacci numbers. So to indicate that this should be an integer, what you do is here you put a colon after the parameter, then a space, and then here you specify the data type. So in our case, this would be then an integer. And we can also do the same thing here for parameters with a default value. So you can also here say colon, and then this show index parameter here should be a Boolean. And then what you do here is when you use those annotations or type hints is then that you put here a space around this equal sign. And then you can also do that here for the return values. So you can specify what data type they should be. And you do that here in between the closing parentheses and this colon here. So here what you then do is dash and then bigger than sign. So you create here this arrow. And then here you can specify the data type. So in our case, this would be then none, because the function is not returning anything. So if you then run it, then you can see that we don't get an error. And this is now how you can use annotations or type hints. Then the next note states that annotations or type hints don't really have an effect. They are just for informational purposes. I.e., they don't raise an error if you pass a wrong type for the parameter. So for example, if I call here this Fibonacci numbers function, and then here let's set a 5 for the n parameter, and then here a true for the show index parameter, then if I run it like this, then our function works as expected, because our arguments here, they correspond to the respective type ins. However, if I now transform this true here into a 1, then the function still don't raises an error, even though we are using here an integer, even though we are supposed to use here a Boolean. And then also, just as a side note, our function here still works, because here we are saying if show index. So, and here we are using here then this 1, and since any integer that is not a 0 is interpreted as true, therefore then we execute here this part of the code, and therefore then here print out those indices. Okay, so this is then what I mean by this note that annotations or type hints don't really have an effect, and they are just for informational purposes. So now let's go over the side note here. And this states that you can also specify multiple types by using the bitwise OR operator. So to demonstrate that, I've prepared here this function. So this is simply called square, takes in a number and then returns the square of that number. So now let's say that you want to specify a type hint for this parameter, and you want to specify that it either could be an integer or a float. So the way that you could do that is by saying here colon and then integer, then space, and then you use here this vertical bar, and then here you can then say float. And you can also do the same thing for the return value. So here you can then say dash bigger than sign, and then here you say integer, space, this vertical bar, and then float. And then this way then you would have specified multiple type hints for this parameter and then also for the return value. Okay, so that is the side note. And with that, now we've covered here all my notes with respect to annotations and type hints. So with that, then we've covered here all the notes with respect to these side notes. And with that, then we've covered all my notes with respect to this note that says here functions can receive input via parameters or arguments. Then the next note states that functions can return output via the return statement. And here the first note states that you can then put the output into a variable so that you can keep working with it. So to demonstrate that, let's use again here this Fibonacci numbers function. And this is a simplified version where we only have here this n parameter. So now if I run it like this, then it simply prints out here those Fibonacci numbers. And now let's say that instead of printing out those numbers, what we want to do is we want to put them into a list. So therefore then here we're going to say list, and this equals then an empty list. And then here within the for loop, we then going to say list dot append, and we want to append the a. And then at the end of this function, we're going to use the return keyword to return then this list. So now if I run it like this, then our function here now returns this list with the Fibonacci numbers, and we can actually then store those lists here into a variable. So let's then say here list underscore Fibonacci, and then let's also print out again this list. So let's print out here list Fibonacci, and then now if I run it again, then you can see that now we have stored this list here into this variable. So this is how we can use the return statement to return some output with a function. So now let's go over the side notes here. And the first one states that you can return multiple values. So to demonstrate that, I've prepared here this function. So this is called min-max, and it takes in a list, and then it determines the minimum number of that list and the maximum number of that list. And now let's say that we want to return both of these numbers. So therefore then we simply say here return min number, and then also return the max number. So then let's call this function now. So let's say that here min max with this list here, which contains 1, 2, and 3. And now if I run this, then you can see that it returns both of these values here within a tuple. So here we have the 1 and then the 3. So that's the first side note here that I wanted to cover. Then the next side note states that you can use multiple return statements within a function definition. So to show that, let's say that we wanted to create a function that determines the absolute value of a given number. So therefore then we would simply say if that number is smaller than 0, then we want to return the negative number, else we want to return simply the number itself. So now if we run this function here with a -5, then we get here a 5. And if we run this function here simply with a 5, then we also get here this a 5. So that's the second side note here that I wanted to cover. Then the next side note states that you can return any Python object, even a function, for example. So to demonstrate that, I've prepared here this example function. So this is called length, and it simply returns the built-in function len. And now if I say here a equals length, then if I print out here a, then you can see that it is the function. And now we can actually use here a, for example, to determine the length of the string hello. So then here we get 5 characters. So that is the third side note here that I wanted to cover. And then the last side note states that when there is just a return keyword itself, or when there is no return keyword at all, then the function automatically returns a none. So to demonstrate that, I've prepared here these two functions. So here we have function 1 and function 2, and in both we simply say x equals 1. And then here in function 1 we have here this return statement, and in function 2 we don't have a return statement. So now if I call here function 1, then if I run this, then it looks like it's not doing anything. However, if I use here the print statement, then you can see that it actually returns here a none. And the same is also true for here for function 2. So let's say here print function 2, and then if I run this, then you can see this also returns here a none, even though here we don't have a return statement. Okay, so with that now we've covered here all these side notes, and with that then we've covered all my notes with respect to this note here that says functions can return output via the return statement. So with that then we've covered here all my notes with respect to the def keyword. And now, however, before I end this video, I also want to go over my notes for Lambda functions. And that's because they can be good explained in the context of the def keyword. Namely, Lambda functions are so-called anonymous functions, i.e. they have no name. And to demonstrate what I mean by that, I've prepared here this example function. So this is called square. And now if I print out here the reference to this function, then we can see that this is a function and it is called squared. And now, however, if I do the same thing here with a lambda function, I would do the following. So I would say here lambda and then space x, and then here we want to have the square of x. So now if I run it like this, then you can see that this is also a function. However, this is simply called lambda. So it's an anonymous function which has no name. And here then, just as a side note, you can also use your lambda functions with multiple parameters. So to demonstrate that, I've prepared here this function. So this is called add. So again, if I print out here the reference to this function, then we can see that it is a function and it's called add. And now if we do the same thing with a lambda function, so here then we say x, comma, y, and then here we want to have x plus y. So then if I run this, again, we can see this is a function and it's simply called lambda, so it has no name. Then the next note states that you can think of them as small one-off functions. And a typical use case is when a function can take in another function as an argument. For example, this would be the case for the built-in function map or the built-in function sorted. So let's look at an example with this built-in function map here. So therefore I have prepared this code snippet. So here we are using this built-in function map, and we will talk about that in more detail when we talk about here the built-in functions. However, now you just need to know that this function here can take in another function. So therefore then we obviously need to first define that function. And then here if I run this, then we get here this result. And this can be, however, done more easily with lambda functions. So therefore then if I simply copy this here and then delete here the square, what we also can do is to say here lambda, and then we want to have x, and then we want to square that. So now if I run this, then we get here the same result. So, i.e. Using a lambda function is basically just a convenience. Namely, in that case, then there is no need to specifically create an extra function with the def keyword for such a small task, which you then also might actually only use once. Okay, so that is the typical use case for lambda functions. And then the last note states that Lambda functions are syntactically restricted to a single expression. So to demonstrate what I mean by that, I've prepared here this code snippet. So here we have a variable called list, and it's a list containing 1, 2, and 3. Then here we define this function mean, and here we first determine the total, which is the sum of the list, and then we determine the mean, which is then the total divided by the length of the list. So if we use this function here, then we get here the result of 2.0. And now let's say that we want to do here the same thing with a lambda function. So therefore then we would say lambda and then list. And then now let's first try to use here this expression. And then secondly, then let's also use this second expression here. So if we try to run it like this, then we get here a syntax error because cannot assign to lambda. And so that means then that we need to do this calculation here in just a single expression. So therefore then let's delete here this total, and let's also delete here this total. So now we just have the sum of the list divided by the length of the list. And now if I run it like this, then here we don't get an error. So this is what I mean by this note that says that they are syntactically restricted to a single expression. Okay, so with that then, we've already covered all my notes with respect to lambda functions. So we've reached the end of this video. And then in the next video, we're going to start to go over my notes for the built-in functions in Python. So thanks for watching, and hopefully I will see you in the next video.